We have AJ Ashton from Mapbox, and he's also going to talk about boundaries.
Thanks. I'm AJ. I'm on the boundaries team at Mapbox, and what the boundaries team does is we collect and manage as many different types of boundaries as we possibly can for use internally to distribute to our product teams, and also basically develop our own external product that you can purchase directly with all of these boundaries collected together and normalized as much as possible and put cleanly into nice usable vector tiles that you can use with Mapbox's APIs. So basically, overall, we've got over 3.5 million polygons in our data set so far, always trying to add more. We've got administrative divisions, postal code areas, legislative districts, statistical boundaries, and more. As I said, I was trying to add more. So basically, a quick overview, just a high-level look at our tech stack. So what I'm going to go into a little bit is just I'll look into how we manage boundaries at a high level, and then do a light dive into a specific technical issue that we have to deal with. It's one of our biggest challenges. So our source data is managed on Amazon S3 as GeoJSON files. It's normalized slightly from basically all the various different sources we get it from. We use PostGIS as a data and geometry processing engine, but we don't actually maintain any long-running databases. We really just use it for the geometry tools. GeoJSON goes into a PostGIS database running in Docker, does some processing for just as quick as we can do it, and then back out to GeoJSON on S3. And we use Tippecanoe for vector tile creation, and all the pipeline is managed through Docker Bash Python. So, one of our biggest technical challenges is dealing with all the different geometries we get when we're combining different data sources. Actually, our probably biggest challenge overall is just collecting the data in the first place and trying to track down good sources. But technically speaking, once we get it, this is the main challenge. So, what we're looking at here is boundary data from two different sources, doesn't line up. It's not, so Greg was talking about like competing claims on boundaries, and that's certainly an issue we have to deal with, but most of the time, it's not really to do with competing claims so much as just like different levels of precision and different methods used in surveying the same sort of boundary definitions. And the way our product works, we want this all perfectly line up in the end. All the polygons need to be totally seamless to look good on the maps that we're trying to produce in the end. So, yeah, how do we fit this all together? So, our data is all organized sort of at the international boundary level. Although it's not technically international boundaries all the time, we use the ISO 31661 definition of regions and countries. So, we divide things up that way just for consistency. Lots of other products and tools do that. So this data set is at least a manageable number of polygons, and these are the international boundaries are the most, sensitive and important ones on many levels. So this we actually manage pretty manually. Normal GIS operations, we use QGIS most of the time. Manage the shapes as we get improved data or have to deal with new issues that arise. It's mostly managed manually, and we can make sure everything lines up pretty much on our own. But as I said, we've got over millions of polygons overall. Once we get to like the deeper levels, manual is not an option. We have to figure out an automatic way to get things all lined up. So some cases are fairly straightforward. This is like a medium level case. Most basic cases are like, can be handled by basic GIS snapping operations that you might find in most GIS tools. This one's a little bit more complicated. So what we're looking at here, we've got orange and green polygons and then there's a blue line. The blue line is our sort of reference international boundary that we want to match up everything to. So our international boundaries are all the way we want them. We want to line up everything else to match those international boundaries. In order to do that, at these two polygons where they meet, we want to sort of expand them out to fill any space that's not that's inside that international boundary reference. So, and ideally, what we'd have here at this inlet, we'd sort of generate a center line for the inlet and expand both the green and the orange polygon out to the middle of that inlet to meet at the middle. And obviously, we don't know for sure that that's the legal definition of that boundary, but at sort of the scale and the purpose of the boundaries that we're dealing with here, it's good enough for our use cases. And for the data visualization use cases, which we target primarily, having the consistency in the shapes overall is slightly more important than 100% precision in getting those boundaries perfectly right. So we developed a solution that worked pretty well for this case, but right away it gets way more complicated. We've got multiple boundaries next to each other here. Weird coastal definitions going on. There's and it's kind of hard to see, but there's a blue outline showing our international boundary reference. By the way, our international boundaries right now, we sort of skirt the issue that Greg was talking about with the maritime boundaries by not even showing maritime boundaries at all. We just sort of cut things off the coastline to keep it simple. Anyway, so we've got this blue boundary line that is our slightly less detailed version of the coastline, but it's the one that is our reference boundary that we want to match everything up to. So how do we fill in all this water space? And again, these polygons are just a part of millions of other polygons that all have a similar issue that we need to deal with altogether. So basically what we've done, it might be hard to see, okay, you can see so what we do, first step, we take the input polygons and we add more vertices to the outlines to get things basically more dense and more even overall. Then what we do is we generate Voronoi polygons at those points and clip them to the space that is the gap that we want to fill in. And then once we have those shapes, we can assign them an ID that matches whatever input polygon they are closest to. And in general, this creates a pretty good looking center line of any shape that you could input here. Not just a nice single stream river that's between two polygons. So then we union everything back together, and that's our result. It's zooming back out a little bit. So that's what it would look like all filled in. So yeah. Trying to remember. Basically, so this process runs for all the boundaries we have. As I said, it's all managed in Docker containers. The process runs in a distributed tiled approach, just to keep everything manageable, and so we can parallelize the data processing. There's so much more I could talk about with our data processing and how boundaries work, but only so much time. So not right now, but if you want to ask me about any of these topics, I could go for quite a while. But if you have any other questions that, sure.
Where are you getting the data? I was recently trying to find zip codes, and zip code shape files or geo packages are not that easy to come by for a lot of places. And so are you getting images and geo-referencing them and just building the polygons out raw, or are you getting them from statistical agencies who are actually shipping you shape files?
We have all kinds of different data sources. Open government data whenever we can get it. The openly available zip code data for the U.S. is not ideal for our use case. So we rely on a lot of other commercial providers for this data, and then we'll do a lot of, once we get that data, we'll do a lot of cleanup on it ourselves from with zip codes in particular. We might do a lot of keyway and cleanup based on our own set of address points that we to verify that the shapes are looking how we want them to. Yeah, it's a really tough problem with zip codes in particular because if you look at, zip codes really are just references to groups of addresses, which are points, essentially. So trying to turn those into polygons is always going to contain some kind of error. So it's a matter of like which errors we want to introduce and which errors we think look the best on our map. Not so much accuracy when it comes to zip codes, but yeah, in general for all of our data sources, it's a wide combination of commercial open data and then some whatever cleanup we can do in-house where it's a priority. But we're a small team, so mostly relying on our data providers to get it as close to correct as possible before we run it through processes like this to make it all consistent.
So, questions about the world views, because I've tinkered a little bit with that. So one, you say you don't show maritime claims, but you do show one maritime claim, right? If you turn on China's, and I don't have a problem with showing the 9-dash line or the 11-dash line, but why not just show the islands, right? Why make the decision to show the boundary around the water instead of just highlighting all the disputed islands as Chinese, which then kind of, abrogates the need to argue about who claims what claim. And then second, do you worry that because you're adding these sequentially, you end up benefiting kind of the loudest, right? Because you start with China, India, you're not all that worried about showing Brunei's claim, and so you end up showing the ones who tend to make the most noise.
That's true, and the answer to both of those questions is more of a, I guess, legal/policy need for actually being able to operate in countries like China that have specific laws about how you display the maps. So the 9-dash line is specifically a legal requirement for displaying a map in China. We couldn't just show the islands. And the same thing, that's why we don't show a version of the map that's for Brunei's, because even if they have a law, we don't have a large enough customer market demand for doing that right now. We might get there eventually, but
as a follow-up to your statement, and I guess your question, do you get a lot of pushback from different entities, countries, whatever?
Yeah. Seems to happen on Mondays for me. Always a new rant in my inbox about how we're showing something wrong.
I've been there.
I was just wondering about the updates. So if you had one of those like boundaries that gets updated, do you do like batch updates across the board, or like if one border gets updated, then you have to update all those intersections? So
yeah. So the way we have the process set up, using parallel and distributed processing, we've got the process down so that anytime we need to make a change, we just reprocess all those boundaries at the same time to make sure that, we do batch them. I guess we'll wait for a significant number of updates to be required, but then we'll update sort of the reference international boundaries at once, but then reprocess all the millions of other boundaries together.
How long does that reprocessing take, just as a general?
It depends, but it's about, for our most complex layer, which is our postal layer, it's about like 4 to 5 hours of processing, plus another 4 to 5 hours of QA checks.
And it's all operating in parallel, so it's many more times that CPU.
Yeah.
Do you work with any, so this is about, mostly tonight is about boundaries where there's one answer, be it right or wrong, or maybe a couple answers. But because of complexity, you're trying to reduce it. Are there any spaces, and I know you will do some maps, so say something that's perhaps less politically charged, like the tide, where you keep more than one layer and sort of intentionally show some sort of overlay, like a simple example of high tide, to play a little bit with that idea of the line?
That sort of thing hasn't been too much a priority for the use cases that we've been targeting so far. It's definitely an interesting problem that, I mean, I've been interested in the past and would like to sort of try and tackle that sort of issue, but yeah,
Or
just
you're solving the
competing
geopolitical
priorities.
problems.
Yeah, so yeah, the main use cases doesn't really matter what the exact details of high tide or low tide look like, as long as, I guess, a sort of basic baseline would be, does it look reasonable over top of our satellite imagery?
Take it a high tide or a low tide.
Yeah.
Alternating usually high tide.
Oh, sure.
Sorry, last question. But you showed when like boundaries don't match up, but what about like overlapping or intersecting boundaries where they're like nested or they're, like how do you reconcile that?
Right. So a step I guess I skipped at the beginning. The first thing we do before filling in the gaps is cutting down any overshoots based on our reference international boundaries. And then in the case, occasionally we'll, luckily most of the data that we're able to source is internally clean, so we don't have to worry about overlaps across like county or state lines. But when that does happen, usually it's limited enough that we can deal with it manually, or otherwise we'll just run a one-off script to deal with that in a similar manner.
Can you talk a little bit about the manual curation of those international boundaries, or any other manual work on boundaries?
I think so. Well, actually, so for international boundaries specifically, we rely on work done by the State Department and open data that they release. Those, in general, are our most detailed and reliable sources. Specific other things will come up where we might prefer data from an individual government for one reason or another, but overall that's our general go-to. And then in some cases it's just a matter of there's only one source available that we could find, so that's the one that we get. All right, thanks.
Thank you.